A very good morning to all of you. Myself Mukesh, Assistant Professor ECA Department at GNIT Greater Noida, affiliated to IPU University, New Delhi. My dear friends, today I am going to discuss about the transient response in any network circuit using Laplace transform. So as you know, any network circuit consists of three basic passive components: resistance, inductance, and capacitance. And we are going to calculate the response in this circuit in two ways. One at t equal to 0 minus and t equal to 0 plus. Another response we are going to calculate for t greater than 0. So two response we are going to calculate across any network circuit known as transient response and steady state response. So if a circuit is a pure resistive circuit, and we know that current across resistance or the voltage across resistance is going to change suddenly. So in such a circuit, the transient response is 0. So I can say that transient response is not possible to calculate for a pure resistive circuit. If I want to find out the transient response in the circuit must contain either inductor or capacitor. If I am going to design a circuit using inductor along with the resistance, such a network is known as RL network. If I am going to design a circuit using capacitor along with resistance, such a network is known as RC circuit. And if I am going to design a circuit by using the combination of all these three, that network is known as RLC network circuit. And in all these three circuits, we are going to calculate the response in two ways. One by means of the time domain approach, that is known as differential calculation approach. And another approach is we can transform the circuit from the time domain to the frequency domain, that is also known as S domain. And such a calculation is known as calculation of response in the circuit using the Laplace. So today's agenda is to calculate the response of RL network, the response of RC network using the Laplace transform. So once I am going to solve the questions using RL and RC network, you have to remember the three steps. One response I am going to calculate at t equal to 0 minus. And if the circuit is a RL circuit, then we are going to calculate the current across inductor for t equal to 0 minus. And that current is going to same at t equal to 0 plus. I mean to say IL 0 minus is equal to IL 0 plus in inductive path. And second circuit is RC circuit. There we are going to calculate the voltage across capacitor at t equal to 0 minus. and that voltage is going to same at t equal to 0 plus. I mean to say Vc0 minus equal to Vc0 plus. And in the second condition, we are going to calculate the response for t greater than 0. So today we are going to first transform the time domain equation in the frequency domain equation and do the calculation. And finally, I am going to get back the response in the time domain using inverse Laplace. That will give you the final solution.